Hello guys, welcome back to my channel Maison African Motives. Still working on engineering science N3. Still guys, if you're new, maybe it's your first time to this channel, you can consider subscribing so that you won't miss any of the classes that we shall be having working on engineering science N3. So we have the first question, which is on question number 2 on moments. Define the moment of force. That is the first question. Okay, we know that actually the moment of a force is the product of the perpendicular force and the distance of the force from the fulcrum. Okay, so that's how we actually define this, and it's just one mark, guys. It is the product of the perpendicular force and the distance that you're given. That will be the moment. Okay, so that's what we had. And on 2.2 we are given a uniformly distributed. Take note, this part is very important. Okay, sorry for that. It's very important here. A uniformly distributed beam with a length of 10 meters has a weight of 5 Newton per meter. So this is uniformly distributed. Okay, sorry, I'm removing this too fast. So we want to construct the diagrams. We're given all the other information. Then okay, let's just say from the first part that we're given, it's a uniformly distributed part, this one. Okay, so let's just have something like this. Okay, so what is happening is that this is uniformly distributed over 10 meters. Okay, over this distance of 10 meters. So that means it is going to be divided in between. This one is going to be divided because it's a distributed, so that it will be a concentrated load. So it's going to be divided in between. From the 10 meters that you had, is going to be divided into 5 and 5. Okay, so this force here is going to be the product, because it's 5 Newton per meter, which is for 10 meters. So it's going to be 5 times 10, which is 50. So 5 times 10 is 50. So you're going to obtain 50 newtons like this. That's for the distributed part. Okay, then let's see whatever we have. And is supported by 2 supports. Okay, one support is 2 meters from the left end. 2 meters from the left end. Okay, so this is your left end. Remember, we said it's divided into 2, this one, so which means there's 5 meters here in between, but there's the one support. A support always faces upwards like this. So this is on the left. Okay, on the left end, 2 meters. So take note, guys, this is 2 meters from the left end. This issue of writing while you're speaking at the same time, you see now it's affecting me. So it's supposed to be something like this. Okay, so sorry for this. Okay, so this is your left end, and in between here we have got 2 meters. Okay, so that's 2 meters from the left end. Then and the other 3 meters from the right end. Okay, from the right end, this is your right end, but 3 meters from, which is going to be somewhere here. Okay, that's another support that you're having here from the right end. That's our right end here. So it's from, which means going back. So there is a distance of 3 meters in between here. So you've got 3 meters. Remember, here there's a distance of 5 meters because we divided this 10 meters. Okay, anyways, let's move on. It holds 3 concentrated loads as follows. 40 Newton on the left. Take note, guys, on the left end there's a 40 Newton on the, which means direct on the left. This is your left end here. So there is something like this. Okay, on the left end, which is 40 newtons on the left end. So that's 40 newtons like this. Okay, let's see another one. And 30 newtons on the right end. So there is 30 newtons on the right end. This is your right end here. Direct at the right end, there is 30 newtons at the right end. Okay, what else do we have? And we have 10 Newton 2 meters from the right. There's a 10 Newton 2 meters from the right. Okay, so 2 meters from the right, just from the right. This is the right, 2 meters just from the right. There's a force of 10 Newton here. So there's 2 meters in between here. From the right there's 2 meters, and this is of what, of 10 Newton. Take note here, is 10 Newton, 2 meters from the right. Okay, so it's 10 Newtons, this one. Okay, something like this. So that's what we had. And remember guys, this 50 Newton is the one that we took from the distributed load of 10 meters, and we said it's going to divide into 5. So which means from this point here to this point is going to be 5, but because of the 3 meters that I'm having here, which means I'm going to remain with the 2 meters out of 5. Okay, and also here I'm going to have 1 meter because it's supposed to be 3 and I'm having 2 and 1. Okay, then here also I used 2 meters here, but in between there is 5 meters, so which means I'm going to subtract 5 minus 2, which means I'm going to remain with 3 meters, so that all in all I'm going to have 10 meters. 2 plus 3 plus 2 plus 3 is going to give us 10 meters like this. Okay, so that was it on 2.21, where we asked to just construct the diagram showing all the details. So all the details are the forces, the distance, all those parts. Okay, then calculate the reactions of the support. Okay, calculate the reactions of the support. In this case, you are not given a condition that the reactions of the support should be calculated from both supports. Is they just say calculate the reaction, so you can take advantage of calculating one, then to obtain another you just use advantage of upward forces is equal to downward forces. Okay, so the first thing, in order for you to have the forces, the moments, you have to take either between L and R like this. You choose one because you're not told to use both, so you're just going to take one, or you can use both, still you're going to obtain the same thing or the same answers. Okay, and the other thing guys, remember this is like a concentrated load throughout, like this is concentrated throughout. Okay, so we are going to have something like this, moments, that is moments about, I'm going to consider L, so you just consider n of your choice. Okay, so I'm taking moments about L in this case. Okay, so if I take moments about L, that means I'm going to calculate R like this. Okay, so like I told you guys from the previous class that when you are given this type of equation, this is when you are referring to moments about L like this, this is your L, you're going to cover L like this. Okay, so you have got these forces. As I've covered L, I'm remaining with the support R, this one, and there are these forces which are on the same side of R, these ones. These forces are going to oppose R because they are moving downwards. R is moving upwards, but this one, because it's on the other side of R and it's moving downwards, yes, but it's on the other side of R, it's going to move hand in hand with R, so it's going to be added to R, but these ones, they're going to be added together on the other side. Okay, so let's start with the moment that you're going to have from R here back to L. There's a distance of 5, this is 2 and this is 3, so it's R times 5, or 5 times R. Okay, so remember you're just using the issue of clockwise moments. Sum of clockwise moments is equal to sum of anti-clockwise moments. Yes, that's the thing. So that's R times 5, or 5 times R like this. So like I was saying, that if we take this this moment here, there is this part which is remaining here, which is on the other side of R here, of 40, so it's going to work hand in hand with R here, so it's going to be 40 times 2. Okay, so we have 40 and 2, that's a 40 by 2 like this, which is equal to these other forces. Now these other moments, they are on the same side of R, but they are moving downwards, which means they are opposite, so you're going to take these all together, you combine them, so it's a 50 back to L. So there's a distance of 3 meters, 50 to L, so it's 50 times 3. that's 50 by 3 like this, plus you move on to this one. It's actually 10 back to L here, so you are referring back to L. So take note, there is 1 meter here, so you've got this 1 meter plus from L to R here there's a distance of 5, so it's 5 plus 1. This is 1 meter here, so it's 5 plus 1, which is 6, so it's 10 times 6, so it's going to be 10 by 6. Okay, you move on to another one. We have 30 back to L again. These ones are taken back to L, so this 30 back to L. Remember, this is from this point to this point, it's actually 5, so it's just 5 plus 2, or 6, because at this point we have 6. So if this is 6, so it's 6 plus 2, which is 8, so everything is 8, so it's 30 by 8. So it's going to give us 30 by 8 like this. All right, so that's what you're going to have if you consider moments about L. So let's combine 5 times R, that is 5R, plus 40 times 2 from your calculator, that's 80, which is equal to 50 times 3, which is 150 from your calculator, plus 10 times 6, that's 60, plus 30 times 8, which is 240. That's all. Yeah, supposed to be 240 there. That's 30 by what? 30 by 8. Okay, which is 240. So what you're going to do is to combine everything here and subtract 80. So you are going to remain with 5R, which is equal to, you combine all these, then transpose 8 to this side, which means you're going to subtract 80. So make sure that you just add these numbers properly, guys. That's 150 plus 60 plus 240, then you subtract 80, that's minus 80, which is 370 in this case. Okay, so divide by 5 to obtain R there. So if you divide by 5 properly, you're going to obtain 74 newtons. Let's cross check, these were newtons or kilonewtons. Okay, these were newtons. Okay, these were newtons, so your R in this case is going to be 74. So this is 74 newtons. Okay, so since I am not given a condition that I'm going to use like both to take moments about both supports, I can actually find L by using upward forces equal to downward forces, because I'm not given a limited condition. So I'm going to use upward forces equal to the downward forces. So the upward forces, you are referring to L and R here, that which are adding, which are going upwards like this. So it's L plus 74. Okay, L plus 74 should be equal to the downward forces, which is the other loads, these ones which are facing downwards. So it's 40 plus 50 plus 10 plus 30. So you have 40 plus 50, you have to represent this, plus 10 plus 30. So this is just summation. Summation means sum, you are adding. Okay, so just transpose this to the other side, which means it's going to be minus 74. So L is going to, you add these together, then you subtract 74. Okay, so that's actually 50, and that's 40 plus 50. Okay, so you have 40 plus 50 plus 10 plus 30, then I subtract 74 in this case. So if I subtract 74, I'm going to obtain 56 newtons. So let's hope, guys, we are all obtaining the same answer, which is 56 newtons. So there is a force of 56 newtons here, which is actually facing upwards like that. Okay, so that's how you can get this information, like how you're supposed to get this. Okay, so they can ask these typical questions, guys. Okay, let's see another question. Draw the shear force diagram. Okay, now we need the shear force diagram. Okay, so just like usual, we need the beam in order to end up with the shear force diagram. So what you're going to do, let's just have a line first. This one is just a matter of assumption. Okay, so it's a matter of assumption. This one, just draw a line, something like this. Let's hope it's going to cover up. Okay, so what is happening here? There is a 40 Newton. The first part here is facing downwards. This photo force is facing downwards. Okay, so take note, guys, it's facing downwards. So which means you're going downwards. From this point you're going 40 downwards. Okay, so which means you're going to reach at minus 40 because it's going downwards. So this is minus 40 newtons. Then it moves a distance of 2 meters to L, which is going upwards. So a distance moved, you just indicate by a line like this. So you moved like this, 2 meters. Then what happened? 56 meters and 56 newtons. This one is actually going upwards. So you're going to add from minus 40, because this is minus 40, which is downwards. So it's minus 40. You add 56. So you just add like this, minus 40 plus 56, because it's going upwards, which is 16. So this one is going upwards until 16. So it's upwards until 16. So you can just indicate something like this. So this is at point 16. Okay, then what happened here? What happened is that between there is a distance of 3 meters. If you are to cross check between after the L to this foot of 50, which is going downwards, there's a distance of 3 meters. So you're going to move a distance of 3 meters, something like this. Okay, then you move downwards 50, that is 50 newtons downwards, because it's facing downwards. Okay, so from this 16 you're going to move downwards, so which means I'm going to subtract 50 from this 16. Let's subtract 50 because it's moving downwards, which is going to give us minus 34. So that's something like minus 34. So you're going to move downwards, straight downwards. Let's move minus 34. Is it's actually below. It's actually something like this is minus 40. So minus 34 can be somewhere here. So this is negative 34. Okay, then that is about the 50. Then there's a distance of 2 meters between up to 74. There's a 2 meter between, so you can actually indicate the distance like this. Okay, then at R here there's 74 newton, which is moving upwards. Take note, guys, 74 newtons upwards. So which means you're going to add whenever there's an upward, you add, downward you subtract. So that's the concept. So it's minus 34 plus 74. That's how you do it. Plus 74 like this, you're going to obtain 40. So 40 is above 16, which is on the positive. So you're going to move upwards like this. But 40 is actually above 16. So let's just say this is your 40 like this. Okay. Then what happened? There is a movement of 1 meter, then 10 newtons downward. Okay. So you're going to move like this, 1 meter. Then 10 newton up downwards, which means it's 40 minus what? 40 minus 10, which is at 30. So 30 is still above 16. So 30 can be somewhere here above this 16. So this is your 30. Then from this 30, yes, that's a 30. Exactly, that's a 30. Then there's a distance of 2 meters in between. Then you move another 30 downward. Okay. So there is a distance in between, then you move 30 downward. So definitely if this is 30 downward, it's going to cover up the diagram like this. So that's 30 downwards like this. So this is the point 30, and now we are at 0 like that. So that is what we had, guys, from this question where you are asked to have the shear force diagram. So when you are given to have the shear force diagram of the information, draw the shear force diagram. That's how you actually do it. So as you can see, it's actually, guys, 12 marks for this. That's 12 marks. So that's how they ask these questions on moments engineering science N3. So not to miss these classes, guys, make sure that you subscribe to my channel, Meson African Motives, and also don't forget, guys, to share our videos, like, comment. Then don't freak out if you're new. Please make sure that you just subscribe and you become part of the family, Meson African Motives, and we move together as we prepare ourselves for the exams which are ahead. So that's it, guys, till we meet again.